A pulley of diameter equal to 1000 mm is keyed to a 50 mm diameter shaft. So a very large size of pulley and small size of shaft by 14 mm square key of length equal to 150 mm. So we have given here square key, width is equal to 14 mm, thickness equal to 14 mm, length is equal to 150 mm. The tension in the slack side of the belt on the pulley is 2500, that is the minimum value of tension is given T minimum equal to 2500 Newton, and the tension ratio is given as 2:1, that is the value of T max divided by T minimum is equal to 2. The factor of safety in crushing by taking the ultimate compressive strength for the key as 350 megapascal we have to find out. Since we are interested in the factor of safety in crushing, so we'll consider here the failure in the crushing. But before this, using T max and T minimum, we'll calculate how much torque is developed. So one equation we'll use as torque is equal to maximum tension minus minimum tension multiplied by the diameter of pulley divided by 2. Second equation we'll use torque is equal to sigma CR multiplied by T by 2 multiplied by L multiplied by D by 2, that is diameter of the shaft, divided by 2. Once you calculate sigma CR, then we can calculate the factor of safety, that is FOS equal to ultimate compressive strength. So we have SUC divided by sigma CR. So these are the steps that we are going to use to solve the problem. So we'll consider here a shaft of diameter equal to 50 mm. So diameter of shaft is same as equal to ds is equal to 50 mm. Over this we have a pulley and the diameter of pulley is equal to dp is given as 1000 mm, and we have shown here a key. The key is a square type and the side of the square is 14 mm. So we have width is same as equal to thickness is equal to 14 mm, and the length of key is given as 150 mm. Let's represent here we have the minimum tension is equal to T minimum and we have maximum tension is equal to T max. We have given here the minimum tension equal to 2500 Newton. So we have T minimum is equal to 2500 Newton. And we have ratio is given as 2:1. It means that we have T max is equal to 2 times of T minimum. So 2 multiplied by 2500 is equal to 5000 Newton. In addition to this, we have given the ultimate compressive strength. SUC is known. That value of SUC is equal to 350 megapascal. First we calculate the torque by the pulley, which is T max minus T minimum multiplied by dp by 2. In this case we have the maximum tension is equal to 5000 Newton. Minimum tension equal to 2500. Diameter dp is same as equal to 1000 mm. So it is multiplied by 1000 and divided by 2. That is equal to 1250 into 10 to the power 3. This answer will come as Newton mm. Now consider here the failure of a key in crushing. In that case, we have crushing area is T by 2 multiplied by L. Sigma crushing we can find out. Torque is known. Thickness is known is equal to 14. L is equal to 150. Diameter of the shaft you have to take as 50 mm. So we have torque is equal to 1250 into 10 to the power 3. Sigma crushing we are interested multiplied by thickness T, that equal to 14 mm. Length L is equal to 150. Diameter of the shaft is equal to 50 divided by 2. From this we will get the value of sigma crushing. If you solve it, you will get the sigma crushing is equal to 47.62 is megapascal. Hence, we have factor of safety is ultimate compressive strength, which is given as 350, and we are working crushing stress is equal to 47.62. So approximately the factor of safety is close to 7.35. A 15 kilowatt 960 rpm motor has a mild steel shaft of 40 mm diameter and the extension being 75 mm. The permissible shear and the crushing stresses for a mild steel key is 56 megapascal and 112 megapascal. Design the key. So we'll assume the key is a rectangular key of width equal to W, length equal to L, T is the thickness. This green area represent here the crushing area, that is T by 2 multiplied by L, and the area represented by this dotted line is the shear area is W multiplied by L. This time we are given the power which is equal to 15 kilowatt and the shaft is rotating with a speed N is equal to 960 rpm. So using the power and the rotational speed we can calculate the torque, because we know that the power is given as 2 pi into N into T divided by 60. So we have power is same as 15 kilowatt is 15,000 watts equal to 2 pi. We have rotational speed equal to 960 multiplied by torque divided by 60. Indirectly here the torque transmitted is given to us. So this value of torque come out to be 149 Newton meter. But for calculation you have to use Newton mm. We have given here the shaft diameter D is equal to 40 mm and length of the key is also known, that equal to 75 mm. We know the standard dimension here, W is normally taken as D by 4 and the T is taken as D by 6. That is the standard dimension we'll use, and we'll confirm the value by calculation procedure are within the limit or not. The permissible value of the shear stress tau is also given is equal to 56 megapascal and the crushing stress sigma CR is given as 112 megapascal. That is exactly 2 times of shear stress. Now consider here the failure of a key in a shear. In that case we have torque is equal to shear stress multiplied by the shear area is W into L multiplied by D by 2, where D is the diameter of the shaft. Torque is 149, that you have to take in Newton mm is 149 into 10 to the power 3. Shear stress tau you have to use as 56 multiplied by width W, that we don't know. Length L is equal to 75 multiplied by diameter of the shaft is 40. So we have 40 divided by 2. Solve this and we obtain the value of width. So we have value of width come out to be 1.8 mm. As per the standard procedure, we have width should be greater than equal to D by 4. So minimum width we want is equal to D by 4. So we have D is equal to 40 divided by 4 is equal to 10 mm. So by calculation procedure the width come out to be 1.8. So minimum width required is 10 mm. So as far as the W equal to 1.8 is considered, the width is very small. In that case we have to accept the value of width equal to 10 mm. Now consider the failure of a key in crushing. So same torque transmitted we equate with sigma crushing, which is given as 112 multiplied by T by 2 multiplied by L is the crushing area multiplied by D by 2. So torque is same as equal to 149 Newton meter. You have to take in mm. So it is 149 into 10 to the power 3. Sigma crushing is equal to 112 multiplied by thickness T, that equal to unknown, multiplied by L. L is known as equal to 75 divided by 2, multiplied by D by 2. We have D is equal to 40 divided by 2. From this we have to calculate the thickness T. This answer is also coming out to be 1.8 mm. Now since this answer is 1.8 is same as equal to width, it means that we have to select, since here the width is same as equal to T, we have to select here the square key. But 1.8 mm keyway is too small, so we have to select W is same as equal to T is equal to 10 mm. So the square key dimension of width equal to 10 and thickness equal to 10 mm is accepted. And the final question we're going to take on the key is the match the pair. We have given here the types of key, and we have list 2 is representing the application area. As far as the Woodruff key is considered, it is normally used for self-aligning. So in this case the A matches with 3. Then we have Kennedy key is normally used for heavy duty, that is B is matched with 2. Feather key is normally preferred in a loose fitting and for light duty, that is C matches with 1. And the flat key is normally used in the case of normal industrial use, so D matches with 4. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.